What's up, everybody? It's me, CJ. Today we're going to be talking about differential equations. That's usually a hard word for me to pronounce, but I got it pretty good that time. So, the basic understanding. A differential equation is any equation with derivatives in it. So, for example, we got one right here we're going to do later. Y prime minus 10y, or y double prime minus 10y prime plus 9y equals 0. Simple. It's a differential equation because it has derivatives in it. So, how do we solve a differential equation? Here, let me turn on this light here so we can see a little bit better. Okay. So, the first step is to find derivatives of solutions. If there may be more than one solution provided. And then the second step is, after plugging it in, make sure the two sides are equal. So, you may not understand those steps, so let's do an example to show you how. So, example, of the following, which are solutions to the differential equation y double prime minus 10y prime plus 9y equals 0? And we got three equations here. So, we're just going to go through each one and check it. So, for check-in number 1, step 1, find derivative of solutions. So, y is equal to 2 sine 3x. Now we gotta find y prime. Y prime is equal to 6 cosine 3x. And then now we gotta find y double prime. So y double prime is equal to negative 18 sine 3x, which I believe is correct. So now, second step, after plugging it in, make sure the two sides are equal. So we're going to plug this into the equation. So y prime is going to be replaced with our y prime that we just found. So negative 18 sine 3x minus 10y prime minus 10 times 6 cosine 3x and plus 9y, so plus 9 times 2 sine 3x. Barely fits in the page. And so this is going to become 60 times cosine 3x, and this is going to become 18 times sine 3x. This is going to become just still minus 18 sine 3x. So right off the bat, you can see some things are starting to cancel here. This minus 18 sine 3x and this plus 18 sine 3x. Can't forget the 0. And then, but not everything cancels because we still got this minus 60 cosine 3x here. So we have 0 is equal to negative 60 times cosine of 3x, which is not a true statement. So this is false. So we'll just write a little x there. Now your teacher might want you to write like a sentence or something, but for time's sake, we're just gonna not write a sentence. But it's basically just explain why it's not a solution in English. So on to number 2. So number 2, y equals 5e to the x. Do the same steps. Find derivatives of solution. So we got y is equal to 5e to the x. Y prime is equal to is it 25e to the x, if I'm not mistaken? And no, is that? Alright, so I just looked at the thing, and it is not 25e to the x. I should have known, used my basic trig rules there, but yeah, it happens. So y is equal to 5e to the x, and then y prime is equal to also 5e to the x, and y double prime is equal to 5 times e to the x as well. Now, that's why it kind of confused me, because I was like, what? It's the same for each one? And I didn't want to get it wrong, so, kind of got me a little confused there. But, so, stuff like that will happen. So, y is equal to that. All right, let's plug it into the equation now. So, we got 5e to the x minus 10 times 5e to the x plus 9, 5e to the x equals 0. So this will turn into minus 50 e to the x plus 45 e to the x and 5 e to the x. So if you notice, we can combine these terms, and then that turns into 50 e to the x minus 50 e to the x, which all cancels out. So 0 equals 0, which is a true statement. So we can check off number 2. That can be a solution. But we still have number 3, where y is equal to c times e to the 9x, where c is a constant. So let's do this one. So y is equal to c e to the 9x, where c is constant. But I didn't need to write that all out, but I did. So now y prime is equal to 9c to the 9x, and y double prime is equal to 81 c e to the 9x. So now let's just plug that in. We got 81 CE to the 9x minus 10 times 9 CE to the 9x plus 9 CE to the 9x. So this is going to turn into a minus 90 CE to the 9x. This stuff will stay the same, 81 CE to the 9x plus 9 CE to the 9x. And as you can see, these will combine together to make 90, and that'll be 90 CE to the 9x minus 90 CE to the 9x. So all these cancel, and forgot to put the 0 here, but now 0 is equal to 0. So this is a solution. So the solutions you could use are 2 and 3. Now, the questions may be a little bit different sometimes. It may say, find a values where y equals e to the ax is solution to y double prime plus 2y prime minus 8y equals 0. Alright, so what you're going to do here is you're pretty much going to follow the same steps. So, but you're going to change them up just a little bit. So, 1, we got a solution here. So we're going to find the derivatives of that. So y is equal to e to the ax. Y is equal to a times e to the ax. And then y is equal to a squared times e to the ax. Pretty sure that's the right answer. So now we just plug it in. So we've got a squared times e to the ax plus 2 times a e to the ax minus 8 times e to the ax. So now that we have this, there's one thing that we can do, and that is factor. So we can factor out of e to the ax. So let's take that out. E to the ax times a squared plus 2a minus 8, which is equal to 0. And now we can factor this out. So do a little bit of mental math here. Look at what it could be. And it looks like it's going to be a plus 4 times a minus 2. And can't forget our e to the ax here equals 0. So whenever any one of these terms is equal to 0, then the whole thing is going to be equal to 0. But e to the ax cannot equal 0. So we can only use a plus 4 and a minus 2. So if we got 0 is equal to a plus 4 minus 4 minus 4. A is equal to minus 4. And then we got this, a minus 2. 0 goes a minus 2. Plus 2 plus 2. A is equal to 2. And then these will be our two a values, where y to the eax is a solution to y double prime plus 2y prime minus 8y equals 0. So now there's many ways that you can solve differential equations, and one of the best strategies is by separating variables. So I got a bunch of steps here, and I got an example here, and I'm just going to show you how to do it. So first step, we got to move dx to the other side. So this is like the first step, the first thing you do whenever you see an equation like this. Immediately, just move dx to the other side. So we should end up with dy is equal to 2xy dx. So times dx on both sides. Now we got to move same letters together. Move numbers with, and if you have numbers that are moving along, keep them with the x, unless they're added or subtracted to from y, which I'll get into a little bit later. So let's move the letters. So y needs to be on this side, and we're going to keep the number over here on the x side. So divided by y, so we should have 1 over y dy is equal to 2x dx. Now when you're dividing them, it's probably better to just keep it as a fraction, and then keep the dy's and dx's towards the end, because the next step is going to be using antiderivatives to solve. So we're just going to put an antiderivative in front of here, and we should end up with a natural log of y is equal to x squared. And you can't forget your plus c's. They're very essential. Okay, so now what we are going to do is we are just going to start using plus c is very important. Remember that. But next up, we got pre-calc stuff and a special property that I'm going to show you. But firstly, the c, since it's different on each side, this one's y, this one's x, this is going to be c1 and c2. You're going to subtract c1. So now you have c2 minus c1, which is equal to just still c. So we got the natural log of the absolute value of y is equal to x squared plus c. So basically what you can do is just cross out the c on the left side every time. So now it's time for some pre-calc stuff where you just solve. So we're going to take the natural log of the absolute value of y, put an e in on both sides. So we should end up with the absolute value of y is equal to e to the x squared plus c. Now how do we get rid of absolute value? Well, you're just going to use a plus or minus. Add a plus or minus. So then we got y is equal to plus or minus e to the x squared plus c. And now I'm going to show you a special property. So this can be simplified when you have pluses in the e exponent. This can turn into y is equal to plus or minus e to the c times e to the x squared. Now you're always going to want to start with the c with the plus and minus, because what you're going to do is create an anything number, which is what I like to call it, which is a. So plus or minus e to the c, while that sounds really weird and scary and stuff, that basically just means any number. So because c can be anything, you got plus or minus, and so you can create any number with that pretty much. So yeah, so we'll say a is equal to plus or minus e to the c. And now you have a nice, easy solution. Y is equal to a times e to the x squared. So that is what we call a general solution. But now what we're going to find is a particular solution. We're going to try and find the solution of a, or the a value, where f of 0 is equal to 4. So the first thing what we're going to do is we're going to solve for a. So we're going to turn this into 4 is equal to a times e to the 0. We're going to take y, plug in the 4, and then we're going to take our x, put in 0. And so 0 squared is 0, e to the 0 is 1. So 4 is equal to a. Now we're going to plug that into the OG equation, which is this right here. So y is equal to 4 times e to the x squared. So this solution would make it so this equation up here has it so f of 0 is equal to 4. So that is how you solve differential equations, by separating variables. Let's jump into a little bit of a harder example. So we got t squared plus 1 times dy over dt is equal to y squared plus 1. So we're going to take, actually I'm going to change this to a dx just to make it easier. Dt, the same thing would apply, but I usually like to use dx just because, I don't know, it's easier. For me at least. For you, maybe you like the t, so just use what you like. So first thing we do, immediately we're going to move the dx to the other side. So we got y squared plus 1 dx x squared plus 1 dy. Now we got to move them to their sides that they belong on. And as you can see, we usually like to keep the numbers with the x. But since y has addition on it, we can't separate it out, like I said over here. So this addition number is going to stick to the y. So, yeah, divided by y squared plus 1, divided by y squared plus 1, and also divided by x squared plus 1, divided by x squared plus 1. So now what we should end up with is 1 over y squared plus 1 dy is equal to 1 over x squared plus 1 dx. Now this is starting to look really convenient if you watch my last video. So now we're just going to take the antiderivative of both sides, and we can't forget, wait, never mind. So we got tangent of negative 1 y plus c. That's what I was going to say, you can't forget, but I forgot we didn't even take the derivative yet. But remember, plus c, always. Plus c. So, and this should be equal to the arctan of x plus c. And we can eliminate the c, so minus c minus c. So tangent of negative 1 y is equal to the arctan of x plus c. And how do we do an arctan? We use a tangent. So tangent of this, tangent of that. So we should end up with y is equal to the tangent of the arctan of x plus c. And that should be our answer. So that's a little bit of a harder example, and that's how you solve differential equations, by separating variables. But sometimes you're going to be presented with a word problem. So for example, down here we got the weight of a yeast. Bro, I need to learn how to like pronounce stuff. I'm not that good. I need to learn some English. So the weight of the yeast population increases with respect to t at a rate that is directly proportional to the weight. At time t equals 10 hours, the weight of the yeast is 200 grams and is increasing at a rate of 5 grams per hour. Now that sounds pretty crazy. Like, what am I even supposed to do? That's what I pretty much said when I first read it. But it is pretty simple. So I wrote some instructions over here. So differential equations talk about a derivative. We already know that. So directly proportional, when you hear that in the thing, that means that the derivative you're going to write is going to have a k in front of the function. And k is going to be equal to a constant. And if it says inversely proportional, that means you're going to have your derivative, and then k is going to be over top of it as the numerator. And then you're going to have your function on the bottom. So write that down if you want. And to tell to tell if they're giving you one of these derivatives in a problem, they will say either increase or decrease at a rate of, or with respect to, acceleration, increases are all derivatives. Just pretty much anything that sounds sort of like that, they're going to be talking about derivatives. And what you usually do is you're going to be finding the value of k, and to do that you need to plug in variables, derivatives, and values. So let me show you an example. So we got the weight of the yeast population. Let me read this again. Actually, we don't need to read it. So the weight of the yeast population increases with respect to t at a rate that is directly proportional to the weight. So as we see, we got like at a rate that is directly proportional. That should give you all the stuff you need. So the weight of the yeast population with respect to t, so that's going to be dw over dt, because weight over t, and is directly proportional to the weight. So equals to k w, which is directly proportional. We got the k times our function. And if it was inversely proportional, k would be the numerator and our function would be the denominator. So very simple. So now we gotta plug in variables, derivatives, and values in order to find what k is. So let's see what we got here. At time t equals 10 hours, the weight of the yeast is 200 grams, and it's increasing at a rate of 5 grams per hour. So is increasing at a rate of 5 grams per hour. That means dw over dt is equal to 5, and the weight of the yeast is 200 grams. So weight is equal to 200. Now what we do, we can just plug that in. So 5 is equal to 200 times w. Oh wait, I messed that up. W is equal to 200, not k yet. So k times 200. Divide each side by 200. So you should have 1/40th is equal to k. And now you can just plug that into your original function. So dw over dt is equal to 1/40th w. So yeah, that's very simple. That's how you use a word problem. And so that's pretty much all I have to say. But I'm going to show you this example here from this worksheet I did. And I'm going to show you how it all ties in together. So we got a kitten weighs 85 grams at birth. During the first 4 weeks after the kitten's birth, its weight in grams is given by the function w. The weight of the kitten at 2 weeks is 100 grams. The rate of change of the kitten's weight with respect to time is directly proportional to the kitten's weight. So the rate of change, that shows that we're going to be using derivatives of the kitten's weight with respect to time. So weight with respect to time, directly proportional. So we're going to have the k up front. And the kitten's weight, that's our function. So we're going to have that w. And then next, oh shoot, I just dropped my pencil. So next, I had to solve the differential equation by separating the variables, remembering that k is a constant when you integrate. So this is basically what we did, where we're separating the variables. So as you can see, I moved dt out of the way right away. I put the right letters on the right side, did the antiderivatives, did my pre-calc stuff, used my pre-calc principle, or use that property I showed you, and then found a, made my equation. And then what we do is, like, with some of this information, we know that the kitten's at 85 grams at birth, and at 2 weeks it's 100 grams. So we can use that to find our particular information to find a particular solution. So with 85 grams at birth, we could use that to find the a value. And then with the knowledge that at 2 weeks it was 100 grams, we could combine this with that in order to find what the k value is, or the constant, and which ends up being some crazy stuff. And then what is the kitten's weight at 3 weeks? All we had to do, once we had this solution, we just had to plug in 3 for k, and then that will give us the particular solution. So that's kind of how it all ties together, and I really want to thank everyone for watching this video. I did it all in one take, so there's a couple mistakes in it, but honestly, wish you luck with your math. I got a math test tomorrow. Hopefully it goes well, and yeah, since we did such a good job today, here's a little bit of coconut water for you. There you go. And here's the coconut water for me as well. Good stuff. All right. Have a good one, everyone. God bless everyone, everything. And yeah. Bye. Have a good test, good school. I need to stop talking. I'm gonna just end the video now.